In this lecture, we'll take a look at some of the issues when dealing with input and output. We already know a few techniques for handling input and output, but there are some issues with it. So with both print and print line, we can't control how we format the output. So what if we wanted to specify the number of decimal places? What if we wanted to align the output in certain widths or certain columns? We can't do that with print or print line. Now we can use a new method which is called printf. And if you have used printf in other languages like in C or C++, it's pretty much identical to it. So if you're already familiar with it, you're good to go. The idea with printf is that instead of concatenating variables, we print this giant string that includes placeholders, or it's also known as format specifiers in our string. So what are these placeholders? Well, the format for it consists of a percent sign and then some character. Now, there are a variety of different placeholders. We're just going to go over the basic ones that you're going to see in this class. So a %s would be our placeholder for putting in a string. %c would be a single character. %d would be integer. Now you might think, well, why d? Why not like I? In some languages, %i does work, but d here represents our decimal. %e would be a floating point number, or like a float or a double in scientific notation. %f would be our float and our double with decimal places. And then %n would be the same as our new line, our /n character. So the way this works is that for each placeholder that we include in our output string, we have to map it to some variable that's going to be printed in place of that placeholder. So if I include like a %d, the program needs to know what integer are we talking about. So the way we handle this is we include a variable in printf for each one of these. So like for example, if I include 2 placeholders in my printf statement, then I'm going to include 2 additional variables as arguments that will be passed when we call printf. And we separate them as commas. So let's take a look at an example which I think will help make more sense. So let's say I have the following code. So I have an integer variable x, which I set to 5, and then I have a double, which I set as y, and it's initialized to 2.5. So when I do system.out.printf, my output string is this whole line right here, this x equals %d, comma, y equals %f %n. And so my placeholders are the %d, %f, and %n. So the placeholders that correspond to values must have a corresponding variable. So I have the x and the y. And it's worth mentioning that the order does matter. There has to be a matching order. So this %d is going to correspond to the value of x, and %f is going to correspond to the value of y. And it's worth noting that the %n, since that's a new line placeholder, it doesn't require a matching variable. We can even use the printf statement to specify the width and the precision when we print a particular number. So the width is just the minimum number of characters that would be written to the output. So what we're saying here is if we have some number, we can specify the minimum number of digits that we have to print. And if we print fewer than the minimum amount, we're going to have some spaces in there, and that's perfectly fine with what we're trying to do here. So the way we do this is we add a number after the % sign, but before the character. So it goes between the % and our placeholder character. So let's take a look at an example. So if I want to print a number that has 6 spaces, or at least the width is 6, is probably a better way to phrase it, I would do system.out.printf and then %6d. And remember, once again, this d is going to correspond to the value that I put next. So this would be the 150. So this is going to print 150, but there will be 3 spaces in front of it. Now, for our purposes here, I'm using underscores just to represent blank spaces. because otherwise you wouldn't really see that there is spacing. But when you actually write your Java programs and you print stuff, you would have 3 blank spaces and then you would have 150 printed. The precision just tells us the number of decimal places that we want to print. And this is a very elegant way of handling decimal places. In fact, I just absolutely love it. I mean, if we try to do this for print or print line methods, we really don't have a lot of control on how we would print out the exact number of decimal places. We could use the decimal format class, but it gets really messy to deal with that. So we want to avoid using that class if possible. The way we handle it with a printf statement is we would add a period and then a number after the percent sign, but before the character. So we're going to put point some number between the percent and the character of our placeholder. And what's also nice about this approach is it allows us to round our numbers. So we could actually round up if we wanted to. So let's give an example here. So let's say I have a system.out.printf and then %.2f, and I want to print 2.5678. So we have this 0.2 right here between the percent sign and the f. And this means that I want to print my number rounded to 2 decimal places. So in this case, we're going to print 2.57. Since we have 2.5678, the 6th part would round up to a 7. So this will allow us to round to 2 decimal places. Now, specifying the width and precision are really great features by themselves, but we can combine the two. We can specify both the width and the precision at the same time. All we got to do is just put in our whole number for the width and our decimal number for our precision. So, for example, I can do system.out.printf and do %6.2f, and then I can pass something like 15.50. So what this means is the 6 tells me that my minimum width is going to be 6 things, 6 items, 6 digits, 6 characters, whatever you want to say, but there are 6 individual things that we're going to print. And then the 0.2 part of it tells me that I'm going to have 2 decimal places. So this is going to print a space, a 1, a 5, a point, a 5, and a 0. Now I need to mention that the decimal point itself does count when determining the width. So that's why I only have 1 space instead of 2. So when you specify the width, just remember that the decimal point is included in that width.